Why? Okay, never mind. Okay, can. Okay, anyway, okay, come. Let's start with okay, let's start with question 1, just to go through. I will assume that most of us have done already, except for Lynette do already. Yeah, I don't know why not hot, but okay. I know actually not cold. Very hot. Okay, anyway, Lynette, the section A, Donovan, section A, and Sekang, section A. Okay, you hold first. I collect from you later. Yeah, Friday. I go through today already. Friday, Friday. Okay, I need to see at least see that you do. Okay, come. Let's start question 1. Okay, question 1 over here, right? Okay, without the use of GC, express the following complex number in the form x plus yi. So what we're doing here is simplifying complex numbers, correct? So the idea for first 2i power 11, we need to break this 11 out to i4 or I square, up to you. Okay, so the idea is that not just I4, but you need to know what is I square, I cube, and yeah, all these three to make life easy. So I square -1, I cube I power 4 is 1. Okay, so need to use this to make life easier. Can all right. Next, so you either do I4 or I square, then you have 5 negative ones, then also can get -2i. Okay, also can. B is just simple expansion. C, rationalize the denominator, so multiply by the conjugate so that you get yeah, the denominator is clean. Okay, same for part D. So this one I won't go through so much. I think most of you who got mistakes are mainly algebra problem lah. Okay, algebra problem. Can Okay, so I'll stay here for a while. Okay, can. All right. So this will be question 1. Okay, let's go. Question 2. Okay. Question 2. Now. What on earth? Okay, so who do question 2? P3. Okay, P3. Okay, so what did P3 do? Okay, question 2, right? What is going on is that Z equals to this over that, right? Same thing also, the instruction is without using a calculator, find the real and imaginary parts of this, right? So the thing over here is that now what he did was he tried to make Z into A plus BI. Ayo, this I. 1 over 2I, like that. Okay? Can so this I, okay, expressed as like that. Then he substitute this into the fraction. Okay, 1 plus Z, 1 minus Z. Then you do all the gymnastics to get this. Okay? Now, the only error that he made, right, is because the question asked to state what is the real part and what is the imaginary part, right? Never state. So the real part is 1, imaginary part coefficient is 2. Okay, so that's 1. Okay, so this is method 1. Okay, method 2. Okay, method 2, or maybe another way to simplify this, right, is that you see that you have half here, right? So this one, life is difficult lah, because you need to deal with fractions. So instead, what you do is to multiply by 2. So instead, right, if multiply by 2 on top and below, okay, what will you get? You will get something like 2 plus 1 plus I over 2 minus 1 plus minus I. Okay, then you continue to do all the way until you get your final answer. Okay, now method 2. Okay, method 2. For method 2, right, instead of making Z like that, straight away we can do 1 plus Z, 1 minus Z, right, as 1 plus that fraction. What's the fraction? 2 plus I, 3 minus, okay. 1 plus 2 plus I, 3 minus I, ayo. Okay, divided by 1 minus 2 plus I, 3 minus I. Okay, and same thing also because now we are dealing with a 4-layer cake. So let's make life easier by multiplying the denominator. Yeah, because of the fraction, it's the same thing, just fraction. So over here, right, this becomes 3 minus I plus 2 plus I over 3 minus I minus 2 minus I. Okay, minus I, this one. Okay, then you can do the same to get your final answer. Okay, so this will be method 2. Can all right. Then for the next part, because he already calculated what is z, a bit hard to see, calculated what is z already. So he take the conjugate, then substitute the conjugate into this form. Or he maybe express the conjugate into another form, then do something like this to get 3 over 2 minus 3 over 2i. So here, we need to write the real part. Real part of z star plus 1 over z would be 3 over 2. The imaginary part of z star plus 1 over z would be negative 3 over 2. So this is method 1. Okay, method 1 use the fact that you already do some things over here. You just take the conjugate sub in. Okay, method 2. For method 2, this one will be using the property where we have a fraction, right? When your complex number, the fraction of a complex number, when you take the conjugate, you can distribute the conjugate into the fraction. Okay, can so what is going on would be you can do something like what is this okay, so your z star plus 1 over z would be equals to original z is 2 plus I, then it will be 3 minus I, right? So what we do is we will change conjugate 2 minus I, 3 plus I, like that. Okay, so this one we apply over here. Okay, this property we will apply over here. Okay, next, ayo, okay, plus 1 over z, right? So it will be 3 minus I, 2 plus I. And then you can continue to do until you get your final answer. Okay, so this is the overview okay, of what's going on for this question. So once again, for this particular chapter, right, for complex numbers, right, because it's a chapter on numbers, surds, and algebra, there are many ways to present the same answer or to present your working. Okay, so the thing is that as long as you follow consistently what you're clear, and you just do it your way, but some ways are more efficient than other way. So if possible, you expand the what horizon, not horizon, repertoire. Yeah, expand your repertoire and then have a wider range of tools to do things. Okay, instead of having to rely always on a plus bi, a minus bi. Okay, think whether got property that help you to save your time or not. Okay, can so that's the idea for this section. Okay, next, let's look at question 3. Question 3, Gavin 1. Yay! Okay. There's more? Okay, you can upload later, but yeah, I can upload now, then I'll see later. Okay, so come, let's take a look at what is this. Okay, question 3, right, is a very easy. Okay, question 3 is a very easy question. Now, the thing is that do you need, because got z over here, right? Do you need to, okay, so sometimes the standard method is to make z into x plus yi, and then you expand everything nicely left and right, compare real and imaginary parts. But do you have to do that all the time or not? Actually, don't need. Because z itself is a complex variable, what you need to do is just make z the subject. Can already. So you multiply z over to this side, cross multiply, you get something like this. Then what you need to do is you take this, right? You divide. So it will be 2 divided by I. Okay. 2 divided by negative I, you get 2I. Okay. Rationalize, you get 2I, or you use GC. Okay, you use GC. The question never say do not use a calculator, right? So technically speaking, the objective is this to simplify this and then to make Z the subject. And then you can use GC to help with this. Okay. Similarly for this part, okay, so from from here, right? Technically speaking, if you can see, what is this? Negative IZ is equals to 2. Okay. Then the next step will be Z equals to 2 over negative I. Then from here, you can GC or use your conjugation, okay, by in your head. Okay. Okay, can So efficiency. Okay. Next, for the second one, we are looking at solving simultaneous equation, right? So equation 1, equation 2, sub 2 into 1, eliminate 2 minus 1 minus 2, doesn't matter. But now you only have your W, right? So make W the subject. So so don't need A and BI. For this question, don't need A and BI. Okay, it's really make W the subject. Only no choice, then we do A and BI. Okay, then your W, throw this down, divide by 2 plus I. Okay, then, right, technically speaking, right, you don't need to do all these steps. From here to here, right, you can use GC because they never say cannot use. Okay, can So yeah, I'm encouraging you to use GC because this is a waste of time. Oh, just type the I. Change mode to complex, then yeah. Okay, can Then after that, right, substitute W into this, then 4 minus I. So after you find W, don't forget to find Z because it's simultaneous equation. We're solving for Z and W. Okay, so everything is still the same as last time. We are still doing the same algebra things in secondary school for this chapter. Okay, so questions 1, 2, 3. Any questions so far? Try. What's wrong with you? Nice, You try. Okay, can. Okay, can. All right. So 1, 2, 3. Okay. Can. Okay. Question 4 I go through because argument and modulus. Okay. So this one is okay. This one I want to say is the slightly more abstract part, or slightly more not. It's just trigo, correct? It's just trigo, but not a lot of people are comfortable with modulus argument. So I'll just do that. Okay. So let's look at 4. Okay. So number 4, right? We are drawing an Argand diagram with the following complex numbers. Your diagram, okay, instruction, read the instruction carefully. Indicate clearly exact modulus and argument. For people give me 2.66 something, hey, please this is exact already. Which level already? Okay, exact value. Okay, and the next thing is you indicate on the diagram, not just right at the side. Okay, so Z1. Okay, so let's find, okay, wait, before that, okay, the modulus of any complex number, okay, sorry. Okay, so if you have, okay, if this is your complex number, right, correct? So the modulus of your complex number will follow Pythagoras theorem. Very easy. Okay, then the argument of the complex number, right? That one depends. Okay, so instead of the argument, right, I would do alpha, your basic angle first. Okay, I will do basic angle and then tangent inverse of modulus b over a, positive version of the fraction b over a. Okay, tangent inverse, opposite over adjacent. Okay, now with this, right, let's take a look at 1. Okay, so Z1 is equals to negative 3 plus root 3i. I think everyone okay lah. Everyone okay already. So this one, okay, modulus is 3 square plus root 3 square. So this one is root 12. Simplify this to root 3. Okay, simplify. Next one, argument of Z1, right? Instead of argument, I'll do alpha. So alpha would take me to tangent inverse of root 3 over 3. Okay, this is root 3, 1 over root 3. So my angle is basic angle pi over 6. Okay, then the next question that we ask is, which quadrant is this complex number in? Second quadrant. Okay, so this will be in quadrant 2, right? And so because of this, the complex number, right, would be somewhere over here like that in quadrant 2. Okay, maybe some of you draw very accurate. Yeah. So if you want, you can put the coordinates. Okay, either you put the coordinates or you mark out the x and y coordinates on the axis also can. Okay, can so you do that. Now then you have your imaginary axis, real axis label. Okay, now what do we do? Where is the basic angle? The basic angle for trigo over here, alpha, correct? Right? So where is the argument? I hate this. Okay, the argument is over here. So this argument of z would be pi minus of pi over 6, right? So this argument would be 5 over 6 pi, 5 over 6 pi radian. Okay? Can? Now then label the modulus. Modulus is 2 root 3, like that. Okay? So remember to label on the diagram. Can Okay, next. Okay, part B. Part B is what? Okay, z square equals to 5 times negative 1 minus I. Okay, so this one will be negative 5 minus 5i. So modulus of z square would be 5 square plus 5 square. So this will be 5 root 2. Okay, simplify to 5 root 2. Now, basic angle. Okay, wait. So argument of z1, right, would be pi minus 5 pi over 6. Sorry. Pi minus pi over 6 to get 5 pi over 6. Okay, here. Alpha is equals to tangent inverse of 5 over 5. So this is pi over 4, 45 degree isosceles triangle. So technically, you don't even need to do this. You know your complex number is going to form a right angle isosceles triangle, right? Don't need to form. So don't need to do that whole thing. So, right, okay, so where is my complex number? Over here. Negative 5, negative 5. Okay, now where is the basic angle? Basic angle over here, alpha. Okay, what is my argument? What's my modulus? My modulus is 5 root 2. Now, then what is my argument over here? So this one, okay, where are we referring from? We are referring from negative pi, right? So from negative pi, we want to rotate clockwise direction, right? So negative pi plus your basic angle. Okay, so we will get negative 3 pi over 4 radian. Okay, can part B. Okay, so technically speaking, right? Technically speaking, the working this part, right, don't need to do one. Okay, the working at this part don't need to do one. You can just draw the diagram directly because just 1 mark per diagram, okay, or on the same diagram lah. Okay, for this question, right, by right is draw an Argand diagram, so only one graph, one axis. Okay, so you need one axis to label all 3, but for the sake of clarity, I think I take all 3 out. Okay, so yeah, but when you go A level, be careful it's an Argand diagram. Okay, part C. Okay, part C over here we have Z4 equals to negative pi I. Okay, so the thing is that this right over here, this number is a purely imaginary number, right? Only has imaginary part. Okay, so this is a purely imaginary number. Okay, so where will it be? Okay, negative pi. So x coordinate or horizontal coordinate is 0. The imaginary, sorry, x coordinate or horizontal coordinate 0. Vertical coordinate will be at negative pi. So, right, what I encourage you to do is maybe draw some thicker line over here to indicate that this is your complex number. Okay, a thicker line. And then you put a 90 degree over here, negative pi over 2. Okay, like that can already. Okay, can Now, if they want you to state, so modulus of Z4 is pi, and then the argument of Z4 would be negative 90 degrees or negative pi over 2 radian. Okay, can also just like that can already. Okay, so there's no working to do, no so-called no working to do. Okay, so that's question 4. Okay, questions for question 4. I think most of us are okay lah. Yeah, most of us are okay. So this one, okay one. Okay, can 4 okay. 5, okay. 5 is the one that some of you may have problem, but I think also majority okay one. So but some okay. First one, argument of a plus ib equals to theta. Okay, a positive, b positive. Okay, because of this, where is the complex number? The complex number is currently in quadrant 1, first quadrant. Okay, so in terms of pi and theta, okay, so over here, imagine so we have a complex number over here with argument theta. Okay, now this is a and b, correct? So this tells me that if we were to drop a perpendicular over here, right, this length is a, this length is b lah. Okay, so now we are looking at negative a and b. So where is negative a and b is actually over here, right? So by geometry, this would be theta. Okay, then the question is, what is the argument of this thing? Okay, what's the argument of this? Where's the reference? The reference is pi. So because of that, the argument of negative a plus ib would be reference pi minus your theta, minus the basic angle theta. Okay, can so this is for part 1. Part 2. Okay, part 2, negative a and negative ib, right? So actually we are taking the negative of both these things, correct? So technically speaking, okay, you have your a and b over here. This is theta, but where is the point that we're referring to? Here, somewhere here, negative a, negative b. Where's the theta? Vertically opposite angles, correct? Where's the reference angle? Sorry, where's the reference part? The reference part is actually at negative pi. And then we need to add the rotation in the clockwise direction. Sorry, anti-clockwise direction. Okay, and because of this argument of negative a minus bi, this will be equal to negative pi plus theta. Okay, can third part, b plus ia. Okay, this one interesting, but I think everyone get it lah. So this one is a and b theta. Where is the b and a? So it will be over here. And then by geometry also, this is theta, right? So what is the argument over here? So this is what they are asking. Okay, so the argument of b plus ai will be equal to 90 degrees minus pi theta. Okay, so this one very straightforward, very, very straightforward. Okay, can. Okay, can. So if you cannot visualize, this is the way to think about it, but if you can visualize like that lah. Okay, can. So I think because you're physics students, you should be stronger at this kind of skills. Okay, A math law, correct, it's A math, correct, should go. It is. Why your one can rotate, his one can rotate? Huh. Oh, okay. Okay. Okay, can. For question 10, so we are extending the idea from question 4 and 5. Okay, so part A, write down the exact modulus and argument of the complex numbers. Okay, so what Zhong Xian did was, okay, so the first one, z, mod z is 2, argument z pi over 3, mod z is root 2, argument w is negative pi over 4, right, correct? Okay, of course it is. Okay, now for part B is the one where we need to make use of the properties of argument and modulus. So what are the properties? So we have z1, z2. So the modulus of a product is the product of the modulus. Wow. And then the modulus of the quotient is the quotient of the modulus. So you can distribute your modulus like that, like the conjugate. Okay? Okay, next. The argument of a product now becomes the sum of the argument. Okay? And the argument of a quotient, right, would be the difference of the argument. Okay? Can Now, last but not least, because of the product, right? So if you raise your, okay, if you were to raise your complex number to the nth power, okay, so it will be the modulus raised by the nth power as well. And if you have your argument of the complex number raised by n, so this will be n times of the argument. Okay? Yeah, n boom. I just n boom. Yeah. Oh, okay, okay. All right. So this is okay, the property that we're going to use. Okay, first. Okay, first one. The argument of W over Z. Okay. The argument of W over Z would be, okay, argument W minus argument Z. Okay. Then will be equals to some number over there. Okay, next, the modulus would be 2 root 2, 2 times root 2. Okay, so Z is 2, this is root 2. Okay, straightforward. Now, next one. The next one, right, we are looking for argument and modulus of that, right? So technically speaking, right, don't need to do this. Okay, technically speaking, you can make use of the property. Okay, you can find W first, but I will make use of the property. Okay, so 1 over W. Wait, sorry. Modulus of 1 over W cube would be modulus of 1, which is just 1, over modulus of W cube. Because you already calculated, so don't waste time. So this would be 2 root 2, just like that. Okay, don't waste time. Okay, don't have to do from scratch. Then argument of 1 over W cube. So this would be argument of 1 minus 3 argument of W. So what's argument 1? It's a real number, right? So the argument is 0. Then minus 3 times of argument W. What's W? Negative pi over 4. So this would be positive 3 pi over 4. Okay, so we can save a lot of precious time by doing this. Yeah, within less than 1 pi. Okay, next. Okay, let's take a look at part 3, Z cube over W. Okay, so the modulus of Z cube over W, which is the modulus of Z coating cube over modulus of W. So this would be 2 cube over 2 factor over 2 root. So this would be yeah. Okay, 4 root 2. Okay. 4 root 2 or 8 root 2 or 4 root 2. Okay, then argument of Z cube over W. This is 3 argument of Z minus argument of W. Okay, so this one over here will be 3 times of pi over 3 minus argument W, right? So this one over here, right, will give us 7 pi over 6. Is it? Yeah, no leh. 5 pi over 4. Wait, what is pi over 3? What's pi over 4? Argument z.
Wait, no, teacher. The answer behind is negative 3 pi over 4.
Wait. So wait, what's this again? What's this again? Not say this is 5 pi over 4, right? Okay, can. Now, so correct. And then I told you before, right, in the lecture, where you visualize your complex number, right? Okay, this is the one. When you visualize your complex number, okay, when the argument is 5 pi over 4, right? Where is 5 pi over 4? It's rotation of 1 pi and a bit more, correct? 225 degree, right? So technically speaking, right, if you were to think in your basic trigo or AMF trigo, right, this is your argument over here. Okay, so this is 5 pi over 4. But the problem is that, correct, the problem is that this one, right, the principal value of your argument would be between negative pi, argument of a complex number, and pi. Okay, and 5 pi over 4 exceeds this one, correct? So instead, right, we need to bring this back one round, 1 whole 2 pi, to get to somewhere within the range. Okay, so how am I going to do this, right? Is that I will need to rotate it 2 pi, correct? So if I rotate it in the opposite negative direction, I need to minus 2 pi. Okay, so this will be equivalent to 5 pi over 4 minus 2 pi. So because of this, negative 3 pi over 4. Now, one more thing to take note is when you're doing trigo questions, okay, when you're doing trigo questions, right, this and this angle is not the same. Both of those two angles are not the same when you're doing trigo. Okay, however, because this is argument, we are looking for the argument of a complex number. So that's why in this question, I can write this equals to this equals to this, because these three are equivalent. Okay, so this question is we are talking about the argument, and these two angles are equivalent. Okay, but when you're solving for trigo, these are two completely different angles. So do not write this, cannot write this. Okay, cannot write these two things. Okay, can so I can write something like that. This is for part 3. Okay, next one for part C. Okay, can so part 3 like that. Okay, so something like that. Okay, let's go on to part C. Okay, any questions for this one? Okay, any questions for this? All okay? Can okay. So let's go on to part C. Now part C, right? They want us to find the argument of ZW. Okay. Find the argument ZW and find ZW in Cartesian form. Use an Argand diagram, deduce that. Okay. So we need to draw some things out lah. Okay. And so where's the Argand diagram? No Argand diagram. Okay. Anyway. Okay. So. Okay. Okay. So first, find the argument of ZW. How you get 1 over half 1 over 12 pi? Yeah, how you get 1 over 12 pi? Where? It's not given, right? Correct? But Z and W is given, correct? Argument of Z plus argument of W. Right? So argument of Z is what? Pi over? Okay. Okay, something like that. Okay, next, find that one in Cartesian form. So this one is done. Okay, so what I would encourage you to do, right, maybe to write out 1 plus root 3 plus negative 1 plus root 3 I in the form of A plus BI. Okay, can Now next, when you look for, okay, the thing is that because of this, right, you cannot jump to this first. Okay, we have to do one more step first. Okay, we have to do argument of ZW. Okay, will be equals to tangent inverse of this. Tangent inverse of -1 plus root 3 and 1 plus, don't need to let, just need to argument this one first. Okay, what is argument of ZW? 1 over 12 pi equals to this. Then you can do your tangent this equals to whatever this is and continue to get your answer. Okay, can So presentation, maybe add one more step to justify why you jump to this step. Okay, because this is a show question. So you need to justify all your steps. Can So show question, you need to justify this. Positive 12 lah. Okay, justify this. This one already justified, and then do this before you jump here. Okay, show question. Okay, so that's for question 10. Thank you. I'll wait. Argand diagram, correct. Argand diagram, need to draw. So the Argand diagram will be here, like that. Okay, so the Argand diagram will be somewhat over here. So this is ZW. Like that, ZW. Like that. ZW. This is pi over 12. This one over here is 1 plus root 3. This one over here, -1 plus root 3. Maybe drop a right angle triangle. So this right angle triangle like that. Okay. Oh, then can jump there lah. Yeah, can jump. Then yeah. Then Zhongxian can jump. So you don't have to do this also. Yeah, can jump from here to there. Yeah. So this one can jump. Sorry, my bad. Okay, because you got diagram. So from the diagram, you come here. Yeah. Yes, need to draw a diagram. Oh. Okay. Can? Okay, so any questions? Questions? No, okay. All good, If I give pop quiz, can do, Okay. Anyway, I quickly do this first. Okay. This one you know how to do now, part 2. You know part 2?
What is square root 6? The square root 6 with all 6.
Correct. What is it, square root 6? Okay, so first, so complex numbers, yes, modulus, this, argument of that. So the thing is, right, we don't have z in the Cartesian form. So we cannot expand this and find w and argument w directly. So the only way that we can do is to make use of the property of modulus and argument. Okay, so part 1. So the modulus of w would be equals to modulus of 1 plus I modulus of z. Okay, so because of this, what is modulus of 1 plus I? This is root 2. Okay, modulus of z would be root 3. So altogether, root 6. Okay, technically speaking, right, if you can see that this is 1 and 1, right, straight away root 2 already. Don't waste time. Okay, you're A level already. This is no longer sec 2. Okay, you can afford to skip some steps over here. Can? You do a lot of Pythagoras already, so I think can jump. Okay, unless it's a show question. Okay, next, argument of W. Okay, argument of W would be the argument of 1 plus I plus argument of Z, correct? Now, and then you already know 1 plus I, first quadrant, isosceles triangle 1 and 1, right? So what's the angle over there? 45 degree, pi over 4. Right? Straight away, don't have to do the whole tangent inverse. Argument of z given pi over 6. So altogether, this one will be 5 pi over 12. Okay, 5 pi over 12. So this is part 1. Okay, part 2. So part 1 is a straightforward one. Part 2. So this one is the slightly challenging one. But after you do once or twice, you roughly know what to do already. Okay, now this one you need to pay attention a bit. Okay, so without using a calculator, find the smallest positive integer n such that w power n is purely imaginary. State the modulus of w power n when n takes this value. Okay, so let me give you the in general first. Okay. Okay, in general, the argument of a complex number, right, will be equals to this whatever angle that is plus 2 pi, multiple of 2 pi, okay, where k is an integer. Okay, so in general, your argument, right, is equivalent to this angle plus a multiple of 2 pi or minus a multiple of 2 pi. Okay, this is a multiple, okay, integer multiple. Okay, then, so this is in general. Now let's analyze this question. Okay, let's take a look at this question. This question over here, right, says that w power n is purely imaginary. So the image that we need to have is that where is wn? Where is the complex number? The complex number will be on the imaginary axis, correct? Right? So here would be wn. Okay, it can be here or it can be there, correct? Right? Agree? Agree? Right? So because we have these options over here, right? So instead of a multiple of 2 pi, because you rotate by 2 pi, right? Instead of multiple of 2 pi, it should be a multiple of pi. So you need to add a multiple of pi. Okay, so for this question over here is for Wn to be purely imaginary. Okay, what happens to the argument? So the argument of w power n would be you refer to pi over 2 or negative pi over 2, doesn't matter. Okay, as long as you take pi over 2 because it's here, correct? Either pi over 2 or negative pi over 2, but you add a multiple of pi so that you get all possibilities over here. Okay, one more time. One more time. In general, a complex number, right? Let's say a complex number over here, you need to rotate 2 pi to get the equivalent argument, right? Equivalent angle. For this question over here, because Wn is purely imaginary, instead of just one case, we have one case above, one case below. So instead of adding multiples of 2 pi, we need to add multiple of pi. So we take pi over 2 or negative pi over 2. We are going to add a multiple of pi. So this will be plus k times pi, where k is an integer. Okay? Can Now, n times of argument w, so n times of 5 pi over 12 is equals to half plus k times of pi. So what I will do, cancel the pi, divide the pi, both sides by pi. So n would be equals to 12 over 5, half plus k. Now the problem is this, that now we have two variables. Okay, so what we are going to do is we are going to run different values of k and we are going to find different values of n. So this is like trial and error. Okay, so when k equals to 0, n equals to 12 over 10. When k equals to 1, n equals to 18 over 5. When k equals to 2, n equals to 6. So this is how we solve for n equals to 6. Okay. Now let's double check and check the logic again. Okay. Now k, right? If k is negative, n would also be negative, correct? If k is negative 1, negative 2, and so on, n will be negative. But n has to be a positive integer n. In the question they already give, n over here is a positive integer. Okay, can And because of this, right, if you go backwards, it's going to get smaller and smaller. If you go forward, right, 6 is the first smallest positive integer that you will see, right? So because it's the first, right, it will be the smallest positive integer. Okay, so
Can you be quiet? Like people try to pay attention.
same lah. Like by the time you quiet, you all here also make noise. So same. It's like that. It's like that. It's now you quiet, right? Then they make noise. Then after that quiet, right? Then you all make noise. It's like that one. Yeah. It's like that. Yeah. So I give up. Yeah. Okay. Can? So when n equals to 6, then they ask us to find the modulus of this, right? So the modulus of this would be just this modulus raised to the power of 6. So this will be root 6 raised to 6. It will become 36 cube. No, sorry. This would be 6 to the power of 3. Then this would be 216. Okay, something like that. Can? So this one over here, right? This over here, this is the special thing for this question. Okay? Same concept. If W power n is purely real or it is a real number, same. Argument 0 plus minus k times pi. Okay? So this one, so this is something that you may see, something new that you may see lah. Okay? So now, and one more thing to take note, because now, right, we are lucky lah. Don't forget, sometimes you need to take note, you may need to test k equals to -1, k equals to -2. Okay, may need to test these values. Okay? You may need to test these values. Okay? For this one, right, when k is negative, the whole thing negative already. But sometimes the formula is such that when you test negative value, you still get positive integers. So you need to do your due diligence. Okay? So this will be question 11. Questions? Any questions? It's okay, I see later. Wow.
Hey, I got more. You tell me, I'll send more. You stay with me. Okay.
Come, kiss them. Okay, Ken, all right, let's move on. Anyone still need? Or any questions?
I mean, I listed it.
Then can. If you listed it out, then yeah.
I hope it's clear. Since n is an integer file.
How you get 6?
Huh?
You get 6.
Oh,
you are 12. Okay.
Can. I didn't show that I tried an error in the previous group.
That is all try error. So actually can. If you can.
I didn't show that I did.
Correct. Yeah. No, you're listing out your results. Okay, okay. I think can. Yeah. Or if you want to list out, just list out. Yeah. Okay. All right. Let's move on. Question 12. Okay, last one. Okay, last one. Okay. Now this question 12, right? Now this one is this was in complex numbers 2. So the one with the polar form and the exponential form. Okay, so you're going to learn this in university lah. That when you do polar and exponential form, right, your multiplication and division of your complex number become very easy. Okay, now, but the problem is that because we don't have that here, they remove this from the syllabus, right? But they take the qualitative part of the effect of operations, that means plus, minus, times, divide, and to put it to complex one. They want us to describe what happens. So this is something new in the syllabus for you lah. Okay, in a way. I'm not trying to predict anything, but first year lah, first year. So may or may not lah. No, as in this is not the first year, but first year where they specify it in this part, they retain this part. They want you to do a bit more qualitative reasoning as compared to calculation. Okay, so let's take a look at what is this here. Point A represents a complex number with this argument. Where is this? Quadrant 2. Okay, so this one over here tells us that A is in quadrant 2. Okay, now points B and C represent the complex numbers I, A, and negative A respectively. So we sketch the points A, B, and C clearly on a single Argand diagram. So what is this? I times A and negative A conjugate. We are doing operation on the A. And we want to see the effect of transformation of your multiplication, negation, and conjugate on the complex number. Okay, so it's the geometrical effect of the operation. Can So means that we are going to look at a series of transformation. Can So how do I make sense of this? So A, right, we already have this. So let's look at point B. Let's look at IA. Okay, now when you multiply A by I, okay, let's take a look at when you rotate, correct, anti-clockwise, but only that 90 degrees, right? Only 90 degree. And what else? Same length, very good. Same length is also another key point. Correct, common sense. But when you extend this to other questions, right, then the common sense doesn't apply anymore. The common sense is lost. Yeah. So you need to bear in mind, it's not just rotating 90 degree, but also keeping the thing unchanged. Why? Because let's take a look at when you multiply, we need to analyze both the modulus and the argument. Okay, so this one over here is modulus of I, modulus of A. So this is 1 times modulus of A, so just modulus of A like that. Okay, so this tells me that the size remains unchanged. Okay, more like the length of that complex thing, right, remains unchanged. Okay, then the argument, right, would be argument of I plus argument of A. So this is argument of A plus pi over 2. So when we plus pi over 2, we rotate anti-clockwise 90 degrees. Right? Something like that. Okay? So this is the math. This is the reason. Do you need to do all this? Don't need. I'm just writing out for you to see. Okay? See and think. So when we have a similar question next time, then you know what to do. Okay? Next, let's look at C. C over here, right? We have this one, right? So let's start with A first. Okay? So whichever order doesn't matter because I think both of them are equivalent. So let's take A conjugate first. So when we conjugate A, right, what is the effect? We rotate. So not rotate, reflect on real axis. Okay, we will reflect on real axis. And then the next step, when we take the conjugate, we will reflect on origin. Or we rotate 180 degrees. Okay? So with these two, right, now let us sketch our Argand diagram. Okay, so let's say my A is somewhere here. Okay, so this is A, or more like point A over here, origin. Okay, so when we rotate B, right, will be a rotation, right? So rotate 90 degrees over here, like that. Okay, 90 degrees. Okay, rotate 90 degrees. Okay, so B will be there. Yeah. Don't need to memorize, you just make sense. So this is making sense, like thinking about this, making sense. Okay, don't have to memorize. Okay, you all physics students are the memory very bad one. You all make sense by concepts. Same, same. I don't have memorized stuff. Yeah, correct. But that's the only memory that we are willing to commit lah, not the whole essay lah. Yeah. Can? So can I'm a physics student also, so I'm also like that. So I don't remember. I just make sense. Okay. Next. Now they also ask us to do something like that. So for part D, right? Okay, point D, they ask us to they are looking for this multiplied by A, right? So they want us to write this out as IA plus IA minus A. So there are two methods to do this. The first method to do, right, is by multiplying. If you multiply, right, you need to find the modulus of this times A. So it will be a root 3 times of A, something like that. And then you need to rotate A by this amount of argument. Okay, by this amount of angle. Okay, so you need to think in terms of the same thing because it's a multiplication. Okay, now, but the thing is also they want us to write it out like that, so it reduces the problem to a sum and difference. When we take a sum and difference of a complex number, we are doing translation or vector addition. Okay, example, okay, example, 1 plus I plus 1 plus 2I. This is 2 plus 3I, right? Correct? So let's take a look at the Argand diagram. Where is 1 plus I? Like that. 1 and 1, correct? Where is 1 plus 2I? 1 plus 2I is like that. Right? This one 2, right? Then this one is plus 2I become 3, right? So in total, the vector addition, you see 2 plus 3I. Okay? Can so hopefully you are convinced by my lousy drawing over here. Can okay? So with this, right, we are actually doing vector addition. So what is IA? IA is the complex number here, correct? So this is vector OB. So treat it like vector OB. Okay, I didn't put equal, I'm just replacing this with OB. IA again is OB. Okay, what is A? Where is A? A is this complex number, A. Correct. So this will be OB minus OA. So if you were to make sense of this, this would be OB plus AB. Right? Vector addition. Okay. So think of this way. We are taking vector OB. Okay. And we need to add vector AB, right? Correct. So you shift the AB tip to tail. Okay. So you're going to do something like this. Wrong. Okay. So AB is here. We are going to extend another length AB over here. Right. So your point D would be possibly over here, or maybe not exactly on the, depending on how you draw, correct? It may be here also. Okay, as long as this length and this length are equivalent. Okay, because you are adding AB ma. Okay, what you're doing, right, is you copy paste AB, paste it over here, like that. Okay, and don't forget to pull D all the way to O. Hang, jialat. I hate OneNote. Yeah, like that. Okay, can. So this is point D. Okay. Now then they ask us, right? What is the geometrical what is the state the state the geometrical relationship between A, B, and D? D equals to? No. Geometrical, we don't put B minus A. Yeah, what does point minus point mean? There's no meaning in point minus point, right? Yeah, so this is where the physics students don't do well. Don't know how to describe. How? So what is this? No, as in they want A, B, D, midpoint, correct. B is a midpoint to A and B. So B is a wait, one line AD. What else? If you want to be a bit more fancy, collinear can. ABD is collinear. No, it's not. the 90 degree is not at AOD. Yeah, me too. I made that mistake. I blurted it in front of the class. Then I see it's not. Yeah, same. Okay, it's not. Because the 90 degree is AOB. AOB, not AB, AOD. The 90 degrees is AOB over here. Yeah. Okay. Now, one last thing. If you want to be much more fancy, A and D lie on the circle with center D, or maybe A and D, right, is a diameter of the circle with center D, B. Okay? No need, just either one. Okay? More options are for you. Okay, so with this, right, technically we will finish complex numbers. On your own, because I think we don't have much time. On your own, what I would like you to work on is question 15. Okay, 15, 24, 26. No, not today. 15, 24, 26. As in to do for fun lah. That kind of thing. Yeah, to do for fun, for practice. Point C. Point C. I forgot point C. Okay, sorry. Okay, sorry, point C. Point C, right, is over here. A, right, you reflect over here, right, and then you flag 180 degree, right? So point C will be somewhere up there. Sorry, thank you so much. Thank you for reminding. Okay, now, what am I going to do is I'm going to give you the pop quiz. Treat the pop quiz well also. Yeah, correct. So this will be a homework. Okay, so can I collect it tomorrow? Friday no SDL. CM.